We're solving problem 5 from the 2024 F equals MA exam. A massless inclined plane with angle 30 degrees to the horizontal is fixed to a scale. A block of mass m is released from the top of the plane, which is frictionless. So our first step in this problem is to realize what's going on. We have a block of mass m sliding down the surface. The incline itself is massless and frictionless and is fixed to a scale. Let's talk about the scale. Well, as this block slides down, you want to find what the readings on their scale as it slides down this plane slant of 30 degrees. Let's draw a free body diagram to show what's going on here. This is the center of mass for the block, let's say. Let's draw. There's really 3 components in this first. So in this vertical one, we have our gravitational force, which we can denote by F sub g. This is simply equal to the mass of the block, which is m, times the force of gravity, which is 9.8 meters per second, or 10 in this contest. Now we have this force, which we can call F perpendicular, as it is perpendicular to the plane. Well, we also realize that this perpendicular, it's perpendicular to the plane. That angle is 30 degrees. And this is a right triangle. Therefore, we can apply the properties of sine and cosine. Using trigonometric identities, this F perpendicular is equal to mg, because this one's mg, cosine of theta, where theta is 30 degrees. And we also have this F parallel. This is F parallel. This is going to be equal to, well, since this one's mg cosine theta, this one has to be mg sine of theta. And since we can use the equation F equals ma, this is the force, we can actually find the acceleration of the block to see if it matters. A is equal to, well, F is ma, so ma, to get an a, divide both sides by m. So this is F parallel over m equals g sine theta. Now notice, since the scale slanted inclined plane is, it does not have a mass, it is massless, our acceleration here is negligible, as no matter what speed or acceleration the block sliding down the surface, it'll always have the same reading on the scale. Okay. Now, we have this, and since the normal force is perpendicular, we can say that this F perpendicular is equal to just the variable n. And we also realize in the next step that the force exerted by the plane on the block cancels out the perpendicular component of the gravitational force. That's why this works. Now, we also have the top part of the diagram. Where F perpendicular simply equals to n. There is this vertical force here. This, that's not good. That's no good. We have this normal force right here. And we also have that the acceleration, but we know that doesn't matter. So, denote this, and we have the horizontal force. So, normal force denoted by n of sub f, and the horizontal, or the vertical force, simply n sub h. and this is n sub v. So that means that, that's not scale, but this is again a good triangle to know. This is 30 and that's 90. We can also apply trigonometric properties. So we can realize that due to this 30 degrees, so we know that the sine of the vertical is equal to n of f times 30, and the cosine is the horizontal component. These are switched. So, we can say that the vertical component is equal to, the cosine of 30 is opposite over hypotenuse, so this is n sub f times cosine of theta, which is again equal to 30. Now, since this normal force is equal to this perpendicular force pulling down on it, it's equal in magnitude, we can plug in mg cosine theta for this n sub f. So the vertical force is equal to mg cosine times cosine theta, cosine squared theta. And this is really what we want to find, the vertical force acting on this, as we know that the vertical force and the force directly acting down on it is equal. So therefore, the force acting down on it is the weight of the scale, and since they cancel out, we know that this is our answer. This is true because there is no unbalanced force. Either if there was, the cube would be falling or floating into the sky. Now, n sub v is mg times, cosine theta is equal to root 3 over 2. So this is simply 3 over 4. Now, on the test, our answer for the vertical force is 3 mg over 4. So this is simply our answer for this problem.